Don't chase marks. Let the marks chase you. You want to understand. You want to learn. And if you want all those tips and tricks to get you full marks in physics, chemistry, and maths, then this channel is just for you. So subscribe, like, share, and comment as you watch this video till the end. Let's now get to the business of earning marks. Mensuration 3D is the topic that deals with surface area and volume of solids, that is, the 3D figures. For example, cube, cuboid, cylinder, cone, sphere, and their combinations. This is yet another topic of senior school maths which many students find difficult. But if you learn it right, it can be very easy. In this video, we will learn the formulas for cube and cuboids and learn to solve the problems, numericals, questions involving surface area, diagonal, internal and external dimensions, open and closed cubes and cuboids, the volume as area of cross section multiplied by the height, and the cost. The number one thing you have to know is to know the formulas by heart for any mensuration question. So that is our tip number one. Tip number one is to know our formulas very, very well. So if we are talking about the cube, we have total surface area 6a squared, lateral surface area 4a squared, volume is a cube, and the diagonal is a root 3. Now let us see how we can remember these, understand and remember. That is your tip number one. To begin with, let us see what is a cube. If we have to draw the cube, we draw it like this. You draw two squares like this overlapping and then join these edges. Simple. So you see, it's a three-dimensional figure where we have each surface as a square. How many surfaces are there? Let me show you these surfaces. You can see this surface. This is your surface number 1. This will be surface number 2. This will be surface number 3. And this will be surface number 4. Now, in addition to that, we will have the top surface and this will be the bottom surface. So you have 1, 2, 3, 4. The sides of the cube, there are 4 sides and one on the top and the other one at the bottom. So our first formula was TSA, that is total surface area. How many surfaces did we see? We saw 6 surfaces. Each one is A. These will be the dimensions for each. What are the dimensions for each surface? Each surface is A units. And so the surface area of one surface is A square and there are 6 surfaces and so it becomes 6A squared. Did we understand the first formula? Okay. Now let us come to the lateral surface area. Lateral surface area, that is area of 4 surfaces. These 4 surfaces are like the 4 walls. If we have a room, then we'll have 1 wall, 2nd wall, 3rd wall, 4 wall. So it can be actually compared with the 4 walls. So if you're sitting in a room, just look around. If the room has all sides equal, then each surface will be A into A, that is A square. And so the lateral surface area will be, since there are 4 surfaces laterally, that is sideways, and so it becomes 4A square. So we understood the second formula. Then we come to the volume. When it is the volume is going to be A multiplied by A multiplied by A. Now remember, volume for any 3-dimensional figure is area of cross section multiplied by the height. Let me draw another diagram for you. So, volume is area of cross section multiplied by the height. Now, area of cross section, you can look at it this way, that if this is the area of cross section, it will be A multiplied by A and then multiplied by the height of it, which is again A. So you will have volume equal to A multiplied by A multiplied by A, and that becomes A cube. So we understood volume formula also well. Now let us look at the next one, which is diagonal. The diagonal is actually when you take this vertex and then you take the vertex across. When you join it up like this, that becomes the diagonal. Now for the diagonal, we have to take this right triangle. Now this is like a three-dimensional thing. Try and understand. I will explain this once again. If you look at this edge, if you look at this diagonal of this square, which is at the base, and then take this vertex and join it up, this becomes the diagonal of the cube. This diagonal of the cube will represent the longest length that can be fitted into this cube, which means they will ask you that you need to find the longest stick that can fit into this, or the longest rod that can fit into this cube. So this will be the longest length diagonally that can be fitted into this cube. So let us understand this part. If you look at this triangle over here, just look at this triangle. Okay? And in this triangle, you will see that this side is A. This one from here to here is actually, if you look at the bottom surface, this end is here and this end is here, and so this portion over here is this length. So if we look at the sides, this is A, and this is 90. Since the hypotenuse square is square of this side plus square of this side. And so hypotenuse will be under root square of this plus square of this, which means it is under root 2a squared. Got that? So this is under root 2a squared. Now if you look at this triangle, one side is A, the other side is under root 2a squared, which means it is root 2 into a, that is a root 2, this side. And so this one will be the hypotenuse of this triangle, which is nothing but the diagonal of the cuboid. So if we use Pythagoras theorem, this square, that is the diagonal square, will be equal to square of this side, that is a squared, plus square of this side will be square of this, which will be 2a squared. And so we will have d equal to under root a square plus 2a square, which is 3a square, and that will be a root 3. Got that? Root of 3 is root 3, root of a square is a. So did we understand all three formulas for cube? Let us look at the cuboid now. So what is a cuboid? The cuboid will have a rectangular surface and another rectangular surface. This is how we draw the cuboid, and then join these edges. Okay, so you see that compared to cube, which will have all sides equal, a cuboid will have the length here, this will be the breadth, and this will be the height. So we have here length, this will be the breadth, and this will be the height. This will be the length, this will be the breadth, and this will be the height. Got that? So if I want the total surface area, I will take this surface, then I will take this surface, then I'll take this surface at the back, and then I will take this surface. Got that? So you will have these four surfaces, and then we'll have the top surface, and then we will have the bottom surface. Visualize this once again. I shall use another color. We will have this surface here, the one which is facing you. Then we'll have this surface which is on the side on the right. Then we'll take this surface which is at the back. Then we'll take this surface which is on the side on the left. Then we have the top surface, and then we have the bottom surface. Understand. Now I'll explain this to you again so that you will remember the formulas. Once you have these formulas nicely fixed into your memory, you will solve any problem, any numerical, any question based on this. So visualize this. Now, if you can't visualize this on your own, then you look at the walls of the room where you sit in your classroom. The classroom will have the length and the breadth, and it will have the height. So if you look at this, this becomes the floor of the classroom. This is the length of the classroom. This is the breadth of the classroom. And this will become the height of the classroom. Now, this portion over here, this surface becomes the ceiling of your classroom. This becomes the floor of the classroom. And these become the four walls. Look once again. This one over here on the left on the side, this one is facing you, this one is on the right, and this one is at the back. All right, now that you understood this, look at our formula. The total surface area will be twice L into B. Now L into B is going to be this surface, that is the ceiling and the floor. So there are two of these which are having the same dimensions, L into B, because rectangle, the area of it is L into B. So you will have two surfaces with L into B, right? Then 2B into H. Where is B into H? Here. Can you see this B into H? Here. So the walls on the right and the walls on the left, if you are seated over here, then these ones will be 2B into H. This also B into H. And then we come to H into L. Where is H into L? This is H and this is L. So this is the wall that is here, and this one is again L into H. This one, they will be the walls facing you here. If you're seated in the middle of the room, in front of you and at the back of you. If you're facing this side, then this will be the wall facing you. This will be at the back of you. Got that? So you will have 2 LB, 2 BH and 2 HL. And when we take 2 common, we will have 2 into LB plus BH plus HL. We have to know these by heart. The lateral surface area will be area of 4 walls. All you have to do is just look at any room where you are seated. The room will have 4 walls. Of course, there are doors and windows also. But the main thing is that you look at the walls. So you'll have this, which is H into L. This will be B into H. And there are 2 of these. Can you see this? Can you see this? This surface and this surface. These are going to be 2 L into H. And then on the side, this one and this one. Are you able to get that? So that will be 2 of B into H. Can you see that B into H here and here? So if you take 2H common, it will be inside the bracket L into B. Let me just show it to you. The area of 4 walls is going to be 2 2HL plus, that is 2H into L, and plus 2B into H, so I'll say H into B, and so that will be 2H, and 2H went out common, and inside the bracket will be L plus B. So we understood the lateral surface area. The formula of lateral surface area is 2H into L plus B, which is the area of 4 walls. Now, let us come to the volume. Now, the volume, as I told you, you have to look at it as the area of cross section multiplied by the height. Area of cross section, look at this. This, if you consider as area of cross section, then area of cross section will be length into breadth, right? And multiplied by the height, so it becomes L into B into H. But you'll say, what if I want to take this as the area of cross section? Fine. This area of cross section becomes B into H, and multiplied by its height will be this, and this is nothing but L. So still we get B into H into L, which is the same as L into B into H. So we understood this as well, right? Now let us come to the diagonal. For that, I will show another diagram. For the diagonal, we will take this vertex and we'll take this vertex, which is directly opposite to that. And we are going to join these like so. This is the diagonal of the cuboid. Now, when you are asked the questions or numericals which ask you find the longest stick that can fit into the box, the longest stick will be along the diagonal like this. Now, in order to get the length of this, we have to take this right triangle. Now remember, here it doesn't look like a right triangle, but if you look at the actual box, the vertical line here and this surface, they are at 90 degrees. This surface over here, this one, is perpendicular to this edge, and this is 90 degrees. Okay, try and understand, because I know sometimes it's difficult to visualize, but nevertheless, understand that this part, this edge is perpendicular to this surface. So this angle becomes 90 degrees, right? So if we take this green line, that gives us this right triangle. Now, don't we know that this is the height of the cuboid? Don't we know that this is the breadth of the cuboid and this is the length of the cuboid? And so, if you look at this length, the yellow, I'm just showing this surface over here, here like so. This surface, I'm showing here, this is your length, this is your breadth, and this yellow line is this one. Okay, this one. Now, this is your 90 degrees, so this becomes your right triangle. Now, if this is the right triangle, won't the hypotenuse square be equal to L square plus B square? And so this side over here becomes under root L square plus B square. Are you with me? Okay. So this one is the measure of this yellow line. Got that? So now look at this triangle. This is also a right triangle with one side as H and the other side as under root L square plus B square, correct? This green one becomes the diagonal, which is going to give us D square is equal to this square plus this square. This side square will be under root L square plus B square whole square plus H square. You're with me? And therefore, your D square becomes L square plus B square, that is the square of this, because when you square this, the square root sign goes, correct? Square root means power half. So half multiplied by 2 gives you 1. So we get L square plus B square, and plus this is H square. Got that? And so when you want D, it becomes under root L square plus B square plus H square. So we have understood all the formulas. Remember, you want to become smart. You want to get your full marks by understanding and then learning to apply those formulas. You will remember the formulas if you have understood. So go through this and then you will have the problems and numericals. That will be a piece of cake. It will be just so easy and you will start wondering, why did I take so much tension for this topic? Okay, so understand the formulas. That is your tip number 1. Learn the formulas. Keep the list of formulas with you. Read it every day. Glance through it. Keep it in a place where you can see it every day and you will memorize it automatically. Remember, our brain is a wonderful thing. It can learn so many things. Alright? So, not to take stress for the topic, now let us see how we answer the questions which are based on these topics. Let's take the variety of it. We will take first the simple ones and slowly go to the complex ones. Alright? So, let's come to question number 1. We are ready to attack the question, right? The surface area of a cube is 1536 centimeter square. Find number 1, length of the cube, number 2, volume of the cube, and number 3, volume of the material of the cube if it is 1 centimeter thick. Tip number 2, identify the facts that are given. The only thing that is given is this. So you got to connect this with the length of the cube. Then you have to connect it with the volume of the cube. So length will connect with volume and then we will come to volume of the material. Got that? So we will write the data and let us see how we are going to solve the question. So I have written the data that is given and we have to find the length of the edge. Now length of the edge, which is A, and that is equal to how much? So draw a simple diagram of a cube and this becomes the edge. This is A, which is the edge here. This is the edge here. Can you see? These are all edges. Now each one of the edges, that becomes the side of the cube, which is A equal to question mark. Now connect with the surface area formula. What is the formula of total surface area? Now surface area of the cube will be obviously the TSA, that is total surface area, and total surface area is 1536 centimeter square. The formula for TSA is how many surfaces are there? 6. Each one is going to be A square. So 6A squared is equal to 1536. You got that? So A square will be equal to 1536 upon 6. How much is that? 6 goes twice. Remain 3. Now it is 33. 6 5s 30. Remain 3. Now it is 36. 6 goes 6 times. So it is 256. That is your A square. So your A will be equal to under root 256, which is equal to 16 centimeter. So this becomes our answer 1. Got that? Simple? Okay. Now we come to the second part. So this was our first part. Second part asks us the volume. Now volume of a cube is going to be A cube because it is A into A into A, and that will be equal to 16 times 16 times 16. So We'll multiply this. 16 into 16 is 256. Let us show the working here. 256 multiplied by 16. It's better to know your 16 times table. 16 6 is 96. So carry 9. 16 5 is 80. So 80 and 9, 89. Carry 8. 16 2s, 32. 32 and 8 is 40. So we have 4096 centimeter cube, and that is our answer 2. Let us come to the third part. In our third part, they are telling us that if the material is 1 centimeter thick, which means let us have visual representation. So remember, this is your tip number 2. You get the visual representation. You draw the 2 squares and connect them like this, and each one of these edges I'm going to show as 1 centimeter thick. Can you see that? So we will have the thickness over here. Can you see this? So if this is your A, which is 16 centimeter, so each one of these edges from here to here also is going to be 16 centimeter. But now if you look at the inner dimension, just like this inner dimension over here, it's going to be 1 centimeter less and 1 centimeter less. Are you getting that? So the inner dimension will be 16 minus 1 centimeter gone from this side and 1 centimeter gone from this side. So it becomes 16 minus 2. Are we understanding? So we are going to have the external length of the cube is going to be 16 centimeter, but the internal length of the cube will be 16 minus 2, which is equal to 14 centimeter. Let me explain that once again. So if we have this being the thickness of the material, so now it has become a hollow cube. Okay, so the outer edge, the external edge or the external length is 16. So the internal length will be from here to here. That will be 16 minus this 1 centimeter here and this 1 centimeter here. So this one and this one will go, and so this part will be 14 centimeter. Did you understand this part? Okay. Now if we want the volume of the material, we have to take the external volume, and from that we have to remove the internal volume. Getting it? Alright. So we will have volume of material will be equal to external volume minus the internal volume. Getting that? Okay. External volume. We already found it. It is 4096 minus internal volume will be 14 into 14 into 14. That becomes 14 cube. So let's find 14 cube. 14 multiplied by 14, you know the square, it is 196, correct? And now we will multiply that once again with 14. So 14 6s 84. Carry 8. 14 9s 126. And so we add 8 to that, it will become 26 and 8 is 34. So we'll write here 4 and we'll carry 13. So 13 is carried over, 14 ones 14 and 13 is 27. So we write 4096 minus 2744. So we subtract and we get 6 minus 4, that is 2. 9 minus 4 is 5. Then we have 40 minus 27, that will be 13. And so we have 1352 centimeter cube as the volume of the material. And that is our answer 3. How was that? Was it okay? Are we understanding it? Good. Question number 2. The sum of length, breadth and height of a cuboid is 9 centimeter. What is 9 centimeter? It is the sum of length, breadth and height of a cuboid. And its total surface area is 21 centimeter square. What is 21 centimeter square? It is the total surface area, that is TSA, and that is 21 centimeter square. Find the longest rod that will fit into this cuboidal box. Now, the longest rod that will fit into the box will be the diagonal. This means it is the diagonal D. So our question is diagonal equal to how much? So what we do is, first of all, we write all the data and we think of the formula that will link the data that is given over here. So tip number 1 is to know the formula. Shall we do that? Now I've written the data. The sum of length, breadth and height is 9 centimeter and the total surface area of the cuboid is 21 centimeter square. This is given to us and we need the diagonal. So tip number 1 says write the formula, and the formula for the diagonal of a cuboid is, do you remember this? Good. Now tip number 2 is connect this formula with what has been given to you. What is given to you? L plus B plus H. This is given, and total surface area. Now total surface area, won't we have the formula for that too? So let us write it. The formula, it is 2 into do you remember this? Yes. So we know this formula as well. Now, tip number 3, connect with what is known, that is this, with what is unknown. Now, what else is known? This. So, we have L plus B plus H, which has to be linked with L square plus B square plus H square. So, how can we get the square of L plus square of B and square of H from L plus B plus H? Won't we have to square this? Tell me, isn't it? So remember, that is your tip number 3. When we apply our formula, so we have L plus B plus H whole square will be equal to L square plus B square plus H square. And plus it will be 2 into bracket LB plus BH plus HL. Got that? Which formula have we used? Do you remember the identity? It is A plus B plus C whole square is equal to A square plus B square plus C square plus 2 into bracket AB plus BC plus CA. Haven't we used just that? Okay. Now, do we know the value of L plus B plus H? Yes. How much is that? 9. So this becomes 9 square. Simple. Now, we copy this as it is. Plus this part. Isn't it the TSA of the cuboid? How much is the value of this? 21. So, we will write here 81 is equal to L square plus B square plus H square plus 21. Got that? Okay. And so we will have 81 minus 21. We transpose this This is plus, so when it is transposed, it becomes minus 21. And then we'll have L square plus B square plus H square. How much do we get here? Very good. But now we want the diagonal. What is our formula for diagonal? It is under root L square plus B square plus H square. So that becomes under root, tell me. Isn't that right? Okay. So now we will write this as under root 4 into 15. Why should I write only 4 into 15? Why shouldn't I write it as 6 into 10? Or why can I not write it as 12 into 5? Now, why did I take this 4? Because 4 is a square number. Okay, so square number means I can find the square root of this. So it becomes 2 root 15 centimeter. And that is our answer. Was this good? Let's come to question 3. 3 cubes, each with side 5 centimeter, are placed end to end. Find the surface area of the resulting solid. Also, find the volume of the resulting solid. Now here the only thing that is given is the side is 5 centimeter. So what is our tip number 1? Tip number 1 is know what is given and get the diagrammatic representation. So if we have 3 cubes, this will be representing 1 cube, 2 cube, and this is the third cube. And so, you see how I'm drawing this? So, 3 cubes placed end to end. Each side is 5 centimeters. So, this is 5, this is 5, this is 5. The breadth is also 5 and the height is also 5. So, surface area of the resulting solid is going to have the length equal to 15 centimeter. The breadth is going to be equal to 5 centimeter and the height is going to be 5 centimeter. Now, if we have the surface area to be found out, we need to know the formula. Remember tip number 1, know the formula by heart. So, we will say TSA of, now this will be called as a cuboid because 3 cubes are placed end to end. And TSA of the cuboid will be 2 into bracket LB plus BH plus HL. Okay, now I'm going to give you time and now substitute the values of L, B and H. Get the answer. Check your steps. Have you substituted like so? Did you get this answer? Get yourself a nice star. Now this was your answer 1. The second part asked us to find the volume of the resulting solid. Now won't it be the volume of the cuboid? So volume of cuboid, what is our formula? The formula is L into B into H. Remember tip number 1. And then substitute it properly. So you will have 15 into 5 into 5, which is equal to 15 into 25, which is 375 centimeter cube. And that is our answer 2. Okay. Question 4. The edges of 3 cubes of metal are 6 centimeter, 8 centimeter and 10 centimeter respectively. They are melted and converted into a single cube. Find the edge of this cube. Now how many cubes do we have? 3. 3 separate metal cubes are melted, and so when they are melted, the volume of this cube and this cube total together is going to give you the volume of the new cube. So how are we going to think we are going to look at the volumes of each, and we go to tip number 1. What is our tip number 1? Tell me. Find the formulas. So what is the formula for the volume of cube? The volume of a cube is a cube. Now this will be your A1, this will be your A2, this will be your A3, and this one we'll call as A4. So we write just that. So after writing this, we are going to take the volume of the fourth cube will be equal to the sum of all the volumes of these 3 cubes. So we write it like so. Then we substitute. A1 is 6, so A cube becomes 6 cube. A2 is 8, so A2 cube becomes 8 cube, and A3 is 10, so A3 cube becomes 10 cube centimeter cubes. So this will give us 216, this will give us 512, this will give us 1000, and those are all centimeter cubes. Total it up, 1728 centimeter cube. So A4 will be cube root of that. So cube root of 1728 becomes 12 centimeter, and that is our answer. Question number 5. The external dimensions of a closed wooden box are 25 centimeter, 16 centimeter, and 11 centimeter. If the thickness of the wood in the box is 0.5 centimeter, find the volume of the wood in the box, the cost of the box if the wood costs rupees 1.50 per centimeter cube, and the third subpart, the number of cubes of edge 2 centimeter that could fit into the box. Now many children who are studying mensuration do not like the topic because of this. They find mensuration topic difficult because of this particular thing. There are too many formulas, there are too many numbers, there are too many calculations, but what we have to do is just follow the tips. What is our tip number 1? You get the formula. Know the formulas by heart. So if we are talking about external dimensions and it's a closed box. When it is a closed box, remember the height also, the inner height is going to be lesser than the outer height, and that is where we use this word closed. I'll come to that a little later. First of all, let us see the dimensions. These are external. So this is the external length, this is external breadth, and this is external height. And then the thickness is 0.5 centimeters. So tip number 2, let us get the diagrammatic representation and let us fill in the data in that. Okay, so that will give us clarity of thought. Let's do just that. Now look at the diagram. This is the length, this is the breadth, and this is the height. These are the external dimensions. From here to here is the length, from this point to this point is the breadth, and from this point to this point is the height. So when I want the volume of the wood, now remember the wood is not the entire volume here because it's hollow from inside. And so we will take the external volume minus the internal volume. Let us see the thickness here. Can you see this? This is the thickness. So if the external length from here to here is the same as from this point to this point, then the internal length will be 0.5 centimeter less from here and 0.5 centimeter less from here. Why? Because the thickness of the wood is 0.5 centimeters. So tell me, what will be the inner length? It will be total external, that is 25, minus 0.5 here, and 0.5 means minus 1. So that will be equal to 24 centimeters. Okay. Now, same way the inner breadth, if outer breadth is 16, the inner breadth will be from here to here. That will be 0.5 less from here, 0.5 less from here. So it will be 16 minus 1, that will be 15. And then even the height from here to here is 11. So because it's a closed box, then we are going to remove 0.5 from here and remove 0.5 from here. So the inner height will be 10 centimeter. If it was an open box, we would have subtracted from this entire thing only this thickness because it would be the open box. Just now it's a closed box. So we have to subtract From the top also 0.5 and from the base also 0.5 you have to subtract. Okay, got that clear? So we write just that. So we have written these external dimensions and the internal dimensions like how I mentioned to you earlier, as I explained to you earlier. Now the first part says volume of the wood in the box we have to find. Now volume of the wood will be external volume minus the internal volume, because internal volume is hollow. Wood is not here in the center, is it? No. And so it will be external volume minus internal volume. So we write just that. So we have written this. Now external volume will be external length into breadth into height. That will be 25 into 16 into 11 minus internal volume will be internal length, breadth and height, the product of it. We're getting it? Okay. Now again, we don't like this, but you have to look at the number patterns. Now look very carefully. This 25 into 16. Isn't 16 4 into 4? Now this is my thinking step. So I will say 25 fours is 100. Okay. So I'll put 2 zeros. Now 4 into 11. So 25 fours 100 we finished. Now 4 into 11 is? Wasn't that good? Tell me. Yes? Alright. Now out here you have to see how we can get this also into something simpler. This is 15. I can look at this as 12 into 2. 15 2s 30. 30 into 10 is 300. Put 2 zeros. 3 into 12 is 3600. Was that good? Alright. Now that you understood, the difference between 44 and 36 is 8. So we will have 800 centimeter cube. Wasn't that easy? And that's our answer 1. Okay, now the second question says the cost of wood we have to find if the wood costs rupees 1.50 per centimeter cube. And so for the cost of the wood, we will take the rate and we'll multiply it by the volume of wood. So the rate is rupees 1.50, but I'll write only 1.5. Multiplied by volume of the wood, we already found it as 800. And so if you remove the decimal point, look 15 into 80 it becomes. Now this you can do in your mind, and that will be 15 8s 120, and so it becomes 1200, and that is our answer 2. Isn't it looking simpler now? Tell me. Okay, all you have to do is just follow the tips. Okay, now the third part, the number of cubes of edge 2 centimeter. How much is the edge of each cube? 2 centimeter. That could fit into the box. Now into the box means inside the box, means won't I be talking about the inner dimensions? So I will say that the inner volume and the volume of these cubes will be equal. And so we write just that. Okay. So let us come to the third part. What we will say? We will say volume of n cubes. Because we do not know how many cubes are there, we have to find the number of cubes. So we'll say volume of n cubes will be equal to the inner volume, or it will be the internal volume of the box. Okay, so n multiplied by a cube will be equal to inner volume, and inner volume is 3600 centimeter cubes. Yes? Okay, so n multiplied by 2 into 2 into 2 is equal to 3600, and so n will be equal to 3600 upon 2 times 2 times 2. So we will have 2 ones and 2 goes 1800 times. 2 ones and 2 goes here 900 times. 2 ones and 2 goes here 450 times. Okay, so n will be equal to 450. So we have 450 cubes will fit into this box, and that is our answer. Are we getting it, children? Are you finding it easy? If you like it, if you find it helpful, put one thumbs up in the comment box. Say you like it. Let us look at our question number 6 now. So now slowly we are going towards complex questions. Now again I'm telling you, mensuration chapter, if you know your tips well, is very easy. Learn the tips, learn the tricks, and get to know the technique of understanding how to solve these questions. Now this is a typical question of a swimming pool. Its length is given 20 meter long and 10 meter wide, and its shallow and deep ends are 1 meter and 3 meter, and the base of the pool is sloping uniformly. Find the capacity of the pool. Understand the words. Capacity means how much water it is going to contain, which means what is its volume. So you have to find the volume. Now in order to find the volume, now remember, this is not a cube, it is not a cuboid, so you need a diagrammatic representation with the data written, and that is our tip number 2. So let's just draw the diagram. Let us look at the swimming pool. This is the shallow end of it. This is the deep end of it. This is the length of the pool, and this is the breadth of the pool. Now our question says that the length is 20 meter and the breadth is 10 meter. And the shallow end here, it is 1 meter, and the deep end is 3 meter. Got that? From here to here, it is 3 meter. Now in order to get the capacity, you have to look at the area of cross section. Can you see this area of cross section? Now this area of cross section is a quadrilateral in which this side and this side, they are parallel. So opposite sides parallel, and so it becomes a trapezium. Can you see this is 90 degrees here? This is 90 degrees here, and so this becomes the height of the trapezium. So we will use the formula. Remember your tip number 1. The formula for trapezium you need to know, which I've done in the earlier video, and that is half sum of the parallel sides multiplied by the height. So we take the area of cross section multiplied by this length. Okay, you can call this as height or whatever, but it is going to be multiplied by this 10 meter. So area of cross section multiplied by this height. If I have to rest it on this face, then this would have become the height. Okay, so we write volume of swimming pool is equal to area of cross section multiplied by the height, which means it is area of trapezium multiplied by 10, which is equal to half sum of parallel sides multiplied by the height of the trapezium. Sum of parallel sides is 3 plus 1. This plus this, multiplied by the height, which is 20, and multiplied by this 10. Got that? So we have 2 1s and 2 10s. So we have here 3 and 1 4. 4 into 10 is 40, multiplied by 10, and that gives us 400 meter cube, and that is the volume or the capacity of the swimming pool, and that is our answer. Now in place of this capacity, they could even ask you how much water can it hold. The water that it holds also becomes the capacity, correct? Now we have got the capacity in meter cube. They will ask you, find the capacity of this or find the amount of water that is in the swimming pool and give it to us in liters. So what will you do? 1 meter cube is 10 to the power. How much? 1 meter cube is 10 to the power 6 liters. So you will multiply this by 10 to the power 6. And those many liters would be the answer. Okay. So let's see another type of question. Another type of question in mensuration for three-dimensional figures is this particular diagram. A whole lot of children get confused for this. Now this is looking like steps and they are asking us to find the volume and the surface area of the solid. Okay. Now the volume is going to be the area of cross section. If we have a regular uniform solid, our volume formula is take the area of cross section and multiply it by this length. You can call this as height also, because if I were to make it stand on this flat surface, then this would become the height. So point number 1 is you have to find the area of cross section. So what is our area of cross section? Now area of cross section is going to be from here to here. This part we will need, and we will have to divide it into number of smaller areas. So each one looks like a rectangle. Can you see this? So now this is 2 meter. This is also 2 meter and this is also 2 meter. This has been given to us. Okay. And so let us see how we So let us see our different areas. Our first area is this one. Now this is a rectangle. The breadth of it is 2 meter and the length of it will be this 2 meter up to here plus this 1 meter up to here and this 1 meter up to here. So this is 2 here, this is 1 here, this is 1 here. So the total length of this is 4 meter. Got that? So our yellow area will be 2 meter multiplied by 4 meter. Now let us come to the second area. The second area is this one. This one will be now again another rectangle. This is 1 meter from here to here and from here to here again 1 meter. So from here to here it is 2 meter. The area of this portion is going to be 2 meter multiplied by 2 meter. And then the third area is this one. This is again another rectangle and it is 2 meter by 1 meter. Did we understand? So now we'll call this as area 1, area 2 and area 3. So it becomes easier. So the area of cross section will be found by writing area of cross section will be equal to area 1 plus area 2 plus area 3. Okay. Now area 1, isn't it a rectangle? And everybody knows rectangle formula. And so it is length into breadth, but we'll just write the dimensions fast. 4 into 2, we'll put bracket, plus area 2 will be 2 into 2. We'll put another bracket and area 3 will be 2 into 1. Got that? So come on, tell me fast. And how much is that? 8 and 6, 14. So that will be 14 meter square. So that is our area of cross section. What is our volume? The volume of a solid like this is going to be equal to area of cross section multiplied by the length or even height. I'm writing it over here as height. Okay. Now you are going to substitute. Get the answer fast. Check your steps. Area of cross section we already found. Height is this 40 meter, 40 meter everywhere. Can you see that? So that is 40. 14 4s 56, and this 0 that will give us 560 meter cube, and that is our answer 1. Did you get that? Give yourself a star and tell me in the comment box whether you got it or no. Let us come to the second part. Now this was our first part. The second part is the surface area. Now for surface area, again, a whole lot of children will get confused for this, not if we know the formula well. What is our formula for the surface area? The surface area actually, if we look at the lateral surface area. Now lateral surface area, I shall show in this color over here. The lateral surface area will be all this, and also the base of it, this part base, and also this part. Okay, so it is going to be a three-dimensional thing. So we have the vertical surface, which is that side, and then the base, and plus you have this. Now in order to get the surface area of this, that is the lateral surface area, we take the perimeter of the cross section. Okay, so perimeter of cross section multiplied by this, the height. Okay, so that will give us the lateral surface area, and then to that we have to add this surface and the similar surface which is at the back. Got that? So we write just that. Shall I explain this once again? The lateral surface area is going to be this area, which is having this as the boundary. Can you see this? This is the perimeter. Now the perimeter will be 2 plus this 2 plus this 2 plus this 1 plus this 2 plus this 1, and plus from here to here. How much is this? This will be 2 plus 2 plus 2, so that will be 6 meter. Plus this, which is 4 meter. Got that? So perimeter is all this you add and then multiply it by this height. So that gives us the area in blue, that is the lateral surface area. But then total surface area means the area of cross section also will be added to that. Area of cross section from this side and even from the other side at the back. Yes, at the back, if you have to see, again another similar area will be there. Yes, so we add all that and we write just that. The lateral surface area we've written as perimeter of cross section multiplied by height. Let us look quickly at the perimeter of cross section. 2 plus 2, that is 4, plus 2, that is 6, plus 1, that is 7, plus 2, that is 9, plus 1, that is 10, and plus 6, that is 16, and 16 plus 4, that is 20. Okay, so perimeter of cross section is 20 meter multiplied by, look at the height of it, the height will be this. So area of cross section multiplied by this, that is 40 meter. And that will give us 40 into 20, that is 800 meter square. That is the lateral surface area. Now we need to look at the area of cross section. Area of cross section we already finished adding 1, 2, 3. How much is that? 14 meter square. And so we are going to say the total surface area, I'll write TSA. TSA is total surface area, will be equal to lateral surface area plus it will be 2 into area of cross section. And so lateral surface area is 800 meter square plus the area of cross section is 2 into 14 meter square. So that is 800 meter square plus 28 meter square, and that will be equal to 828 meter square, and that is our answer. Answer 2. So I'm sure you have understood the basics of this, going up to the complex situations where we took number of questions. It means a lot to me if you found this video helpful. So write in the comment box yes. Thank you for watching. For more information on the concepts of maths, physics, and chemistry, subscribe to my channel and click on the notification